Good afternoon. Today my topic is from the chapter Metal Non-Metals, and it is reaction of metal with oxygen. Metallic oxide. So reaction of metal with oxygen. Okay. So let's know that what will it form when a metal is reacting with oxygen. When metal is reacting with oxygen, it is forming metal oxide. Okay, whenever metal is reacting with oxygen, it is forming metal oxide. Now here I have shown you the reactivity series of metals, where the upper level is the most reactive metal and the lower level is the least reactive metal. That means potassium is the most reactive metal and platinum is least reactive metal. So let's start with potassium. Okay, when potassium is reacting with oxygen, okay, we know that it will form potassium oxide. Now the valency of potassium is 1 and the valency of oxygen is 2. Okay. So the formula of potassium oxide will be K2O. Okay. Next we are having sodium plus oxygen, again NaO. Again we are having that valency of sodium is 1 and valency of oxygen is 2, then Na2O, sodium oxide. Okay. Now these two are most reactive metal. That means it reacts in room temperature only. Reacts in room temperature only. Next we are coming to calcium and magnesium. They are little less reactive, so here we need slight heat. We have to heat these two metals slightly to have the reaction. So calcium plus oxygen, calcium oxide. Now the valency of calcium is 2, oxygen is also 2, so CaO, calcium oxide. And magnesium also, and heat is required. That is why I am giving the triangle. Triangle is denoting the heat. Magnesium also having valency of 2, so crisscross, it will cancel, and we are having MgO, that is magnesium oxide. Now next move on to aluminium and zinc. Okay, aluminium and zinc, they are little less reactive, so little more heat is required here. Aluminium plus oxygen, okay, more heat required. Aluminium oxide. Now the valency of aluminium is 3 and oxygen is 2. Now crisscross, Al2O3. Okay, aluminium oxide and zinc oxide. It is also having 2, 2, so cancel ZNO. zinc oxide. Now let's balance all this. Here the balancing will be 2K, 2Na, and here 2, no, here we should write 4K, 4Na, then 2K2, 2Na, 2O, and here 2Ca, 2CaO, and 2Mg, 2MgO. Here we should write 4Al and 3O2, then 2Al2O3, and here 2Zn plus O2, 2ZnO. So we have done the balancing already. So we have that potassium is making potassium oxide, sodium is making calcium oxide, calcium is making magnesium oxide, aluminium is making aluminium oxide, and zinc is making zinc oxide. From calcium to zinc we need to heat the metal, but sodium and potassium, they are so reactive that it already react in room temperature. Now next is iron. Okay, in case of iron we need extensive heat. That is why when we are doing any experiment we use iron fillings. What we use? Iron fillings to have the reaction much easily. So let's rub this one. And should write iron reaction over here. Iron plus oxygen, FeO. Okay. Now here iron is having variable valency. It can have 2, it can have 3. So when iron is having 2, then both are cancelling each other. So FeO, iron 2 oxide, the name of this is iron 2 oxide. Okay, and if iron is having the valency 3, then crisscross is 3. Okay, so 2 will be here and 3 will be here. Fe2O3, that is iron 3 oxide. Okay, iron 3 oxide. Now if we are adding this 2, then we can have Fe3O4, that is called iron 2 3 oxide. Okay, so we have done the reaction of iron with its variable valency. Now we should come to lead and copper. They are least reactive. They are least reactive. Only the upper layer of these metals can react. So lead reacting with oxygen, lead oxide, okay, and copper also reacting with oxygen, cupric oxide, but they react very slowly, and only the upper area of this metals, the upper portion or layer of this metal can react very slowly, very slow reaction, because they are less reactive. Now we have left here gold, silver, platinum. They are so less reactive that there is no reaction with oxygen. That is why gold, silver and platinum is having the shine, very long lasting shine, because they won't react with oxygen, so they don't corrode. But other metals which react with oxygen very fast, that are corroded very soon. That is why gold, silver, platinum is having the shine, because they don't corrode. Okay. Now we are having oxides. Now we should know the nature of the oxide. What is the nature of metallic oxides? That we should know. What is the nature of metallic oxides? Nature of metal oxide, that we should know. And to know that, again we have to do one experiment. We should have 3 test tube in which you are having water, and now you are dissolving K2O in first, you are dissolving Na2O in second, you are dissolving MgO in third, and you are dissolving CaO in fourth. Now, after dissolving these oxides in water, do one thing. We are doing that, we are putting one red litmus paper in this solution. We are putting red litmus paper in this solution, and we can see that the red litmus will turn into blue. The red litmus will turn into blue, and we all know that the solution that makes red litmus blue is specifically basic in nature. So in this way we came to know that the oxides of metals are basic in nature. That is why it is making red litmus blue. So we can write that metal oxides are basic in nature. Now what reaction exactly is happening over here? K2O plus H2O, it is forming KOH, potassium hydroxide. Then Na2O plus water, NaOH, that is sodium hydroxide, and then calcium oxide plus water, CaOH whole twice, calcium hydroxide. Now why it is 2? Because the valency of calcium is 2, and again MgO plus H2O is MgOH whole twice, magnesium hydroxide. And with this experiment we have come to know that these hydroxides are basic, and also from the formula we are having hydroxyl group over here, and when we are having hydroxyl group, the compound must be basic in nature. Okay. Now, one very interesting thing I am going to tell you, that as we know that the nature of metal oxides are basic, but there are some oxides which actually show both the nature, acidic and basic. This type of oxides are known as amphoteric oxides. These types of oxides are known as amphoteric oxides. Now, what are those oxides? Al2O3 and ZNO, aluminium oxide and zinc oxide. How? If you react aluminium oxide with sodium hydroxide, that is base, you will have NaAlO2. The name of this is sodium aluminate, and it is a salt. And water. Okay. Again, if you react aluminium oxide with acid, hydrochloric acid, then also it is forming AlCl2 plus water, that is aluminium chloride. Again salt, and water. Now you can see that when it is reacting with base, it is showing acidic nature, and when it is reacting with acid, it is showing basic nature. So it is showing both the nature. That is why it is known as amphoteric oxide. Now let's have zinc oxide also. In zinc oxide, when you are reacting with NaOH, here it is forming NaZnO2 plus H2O. This is sodium zincate. This is salt. And if you are reacting zinc oxide with HCl, then also ZnCl2, that is zinc chloride, that is also salt, and H2O. So when zinc oxide is reacting with acid, it is showing basic nature. When zinc oxide is reacting with base, it is showing acidic nature. So again, it is showing both the nature. That is why zinc oxide and aluminium oxide are amphoteric oxide. So in my today's lesson, I have taught you about the reaction of metal with oxygen. Then we have learned the nature of metal oxide, that is basic. Then we learned about the amphoteric oxides. So for today it is it. In my next session I will continue this chapter with you. Till then, bye. Thank you.